Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 5 from the February-March 2024 Cambridge 9709, paper 1, variant 2. This is pure maths paper 1. And this question here is about a curve which has the equation y equals 3 over 2x squared minus 5. And we want to find the equation of the normal to the curve at the point 2, 1, giving your answer in the form ax plus by plus c equals 0, where a, b, and c are integers. So it's very important for us to read the whole question in the beginning, because many students in the end, when they found their answer, even though they did everything correct, they might leave the answer in the form y equals mx plus c, or they might put it in this form and they might have a, b, and c, some of them not being integers. So you have to be very careful about how we read the question and give answers accordingly. So now, we want to find the equation of the normal to the curve. Now, what does that mean? Well, what it means is the following. Supposing we have a curve that looks like this. Now, I'm not suggesting that this curve looks like this anyway, but just there's a portion of the curve that looks like this, for example. And supposing this is the point 2, 1. Then the tangent to the curve is basically a straight line which has the same gradient of the curve at that point. So it wouldn't look like that. It would be a bit more like this if we did it accurately. It would be the same gradient of the curve at that point, something like that. So it would share the same gradient of the curve at that point. That's not a normal, that's a tangent. Okay, that's called the tangent to the curve. Now, the normal to the curve is basically a line which is perpendicular to the tangent going through that same point. So it has to be perpendicular to the tangent, but going through that same point there. So that's a right angle between the tangent and the normal. Okay, and what they're asking us to find is the equation of the normal to the curve at this point for this particular curve. That's what they're asking us to find. We want to find the equation of this line in this form, ax plus by plus c. So that's what they're asking us to find. So what we can do to find that is, we know that the normal, any straight line, okay, we can find the equation of any straight line with 2 bits of information. One bit of information is we need the point on the line. So we already have a point on the line 2, 1. That's fine. So we got a point on the line. That's good. Right, we have a point on the line. That's one thing that we need. Another thing that we need is the gradient of the line. If we have the gradient of the line, then with these 2 bits of information, we can find the equation of the straight line very easily. Okay, so our task now is to find the gradient. We haven't been given the gradient of this line directly, but we know 2 things that will help us. One of them is that the tangent is perpendicular to the normal. So that means the gradient of the normal is equal to the negative reciprocal of the gradient of the tangent. Okay, so if I find the gradient of the tangent and I change its sign and I write its reciprocal, I will therefore have the gradient of the normal. Okay, so finding the gradient of the tangent is what is important. So we know that the tangent to a curve shares the same gradient as the curve at the point at which it's a tangent. So the gradient of the curve at 2, 1 will be equal to, okay, the gradient of the tangent. Okay, so the gradient of the curve at x equals 2, which is when you find dy dx and you replace x equals 2, will be the same value as the gradient of the tangent, and then the normal will be the negative reciprocal of that. So we need to find dy dx. So we have y equals 3 over 2x squared minus 5. I need to differentiate this expression. Now, to differentiate this expression, I want to get it ready for differentiation by writing it as y equals 3 times 2x squared minus 5 to the power of negative 1. Right? All the variable terms, like the x terms, should be written on the top, even if it's a whole bracket. Now, to differentiate this, I'm going to use what's called the chain rule, because we have a function inside the function. So first of all, we take like the main function, we multiply by the power. So minus 1 times 3. We leave the function as it is, 2x squared minus 5. Then we take 1 from the power. But then don't forget, very important, which a lot of students forget to do, multiplying by the differential of what's inside the function. So multiply by, now here if you differentiate what's in the function, it's going to be 4x. So you multiply by 4x. All right? Remember, it's not just the number that's here, it's the differential of what's inside here. I'm sure a lot of people have been written 2 because they're used to seeing questions where it's just like 2x minus 5, not 2x squared minus 5 like we have in this case, right? So don't be very careful. What we're multiplying by is the differential of what's inside the function. So normally if it's just 2x, it becomes 2. Right? But this is 2x squared minus 5, so it becomes 4x. Minus 5 becomes 0, so 4x. So very, very careful about that. Okay, so that means dy dx is minus 3 times 4x, which is minus 12x. I'll write this over 2x squared minus 5 squared. Okay, that is the gradient function. So we know when x equals 2, was it when x equals 2? At the point 2, 1, yeah. When x equals 2, because we're looking at the point 2, 1. All right, when x equals 2, then we can say the gradient of the tangent is equal to minus 12 times 2 over, and you have 2 times 2 squared minus 5, and all of that is squared. So you have minus 24 over, that's 2 times 4, which is 8, 8 minus 5, which is 3, 3 squared, which is 9. So this can simplify. 3 goes into both of those. That's going to be minus 8 over 3. So the gradient of the tangent is negative 8 over 3, which means, therefore, that the gradient of the normal is going to be positive 3 over 8. Okay, so the diagram here is kind of like the other way around. It doesn't make any difference. This is just to illustrate that the normal has got a positive gradient and the tangent has a negative gradient. We wouldn't know that just by looking at the equation. That's fine. That was just to give you the concept. So we know that it has that gradient and it goes to the point 2, 1. So now we know the gradient and the point it goes through. The rest is pretty simple. We can use the formula which I much prefer. Y minus y1 equals m times x minus x1, in which case you have y minus the y coordinate of the point, which is 1, equals m, which is 3 over 8 times x minus the x coordinate of the point, which is 2. Now, because we want these to be integers, in the form ax plus by plus c equals 0, I would here multiply both sides by 8, in which case I get 8y minus 8 equals, and then I'll expand this bracket without the 8 there because we've already got rid of it, 3x minus 6. And to make it complete, the best thing, I prefer to write the x term as a positive. It doesn't matter if you do it the other way around, but I just prefer to have the x term positive. So I'll have 3x minus 8y, and I'll have minus 6 plus 8, which is plus 2, equals 0. So in the end, you just write it 3x minus 8y plus 2 equals 0. You could have, if you wanted to, wrote it as 8y minus 3x minus 2 equals 0. It's the same thing. It's just you multiply both sides by minus 1. I prefer to leave it in the form where the x term is always positive, but both are perfectly fine. Now, just for those students who are stuck on using the method of y equals mx plus c always, I'll just do that here as well. But I prefer you guys to move on to this more grown-up version of finding the equation of a straight line, because when it comes to more complicated gradients later on, it makes life easier for you. So here, if you did it the other way, you would use the same values here, but the y would be 1, the m would be 3 over 8, the x would be 2, and you have to find what c is. So you end up with 1 equals, they cancel 3/4 plus c, so 1 minus 3/4 is equal to c, so c is 1/4. So we end up with y equals mx. Now m is 3 over 8, so 3 over 8x plus c, which is 1/4. And in the end, you have to write this as, you can't leave it like this. This is the thing that many people might have done without reading the question carefully. A, b, and c must be integers, and it has to be in this form. Ax plus by plus c equals 0. So it has to be, say, 0 on the other side. So you have to multiply here by 8, I think, both sides. We'll get rid of the fraction. So you have 8y equals 3 over 8 times 8 is 3. So 3x, 1/4 times 8 is 2 plus 2. So again, you can either write it like this, 3x minus 8y plus 2 equals 0, or you can write it as 8y minus 3x minus 2 equals 0. Don't forget to put equals 0. Many people, they just write 3x minus 8y plus 2, and they forget the equals 0 part. you are liable to lose marks because this is an equation. It has to have an equal sign, has to have a left-hand side, has to have a right-hand side. Okay, so be very careful about that. So that concludes this question number 5 about the equation of the normal of this curve. Okay, so please take care to read the question, express the answer in the correct way. You don't want to be throwing away marks for silly things like not reading the question properly. Like some people say, find the equation of the normal to the curve at the point 2, 1, and they stop there. The rest is just decoration. The rest of the question, for them, it's just decoration. We don't have to care about it, but you do have to care about it because if you left your answer in this form, okay, you would definitely lose marks. And I'm sure many people did. Okay, so be very careful about it. And some people might have written it something like this, but kept everything as a fraction, like 3/8x minus y plus a quarter equals 0. Again, not expressing the numbers as integers. They will also lose marks. Integers are whole numbers. Okay, so please take care of those matters. They're very important. You don't want to be throwing away marks. So other questions from this paper can be found in the playlist that will appear in this section over here at the end of the video. Other questions from the topic of differentiation from P1 of Cambridge can be found in this playlist over here. I'll also include some work from P1 of Edexcel for differentiation and also P2 of Edexcel of differentiation here to give you more exposure to different types of questions because my Edexcel material has got a lot more in it right now. So you can see other examples from those. Thank you for watching and see you soon.